A piece of iron is heated in a flame. It first becomes dull red, then becomes reddish yellow, and finally turns to white hot. What would be the correct explanation for the above observation? As a piece of iron is heated, it emits thermal radiation at different wavelengths depending on its temperature. According to Wein's displacement law, the peak wavelength of radiation emitted by a black body or any object approximating a black body is inversely proportional to its absolute temperature. So we have Wein's law given by lambda max is equal to B by T, where lambda max is the wavelength at which the emission is strongest. T is the absolute temperature and B is Wein's constant. As the temperature of the iron increases, it first glows dull red at lower temperature. As the temperature rises, it turns reddish yellow. At even higher temperatures, it appears white hot. This change in color is due to the shift in the peak wavelength of the emitted radiation towards shorter wavelengths, that is from red to yellow to white as the temperature increases. This observation is explained by Wein's displacement law, which relates the color of the emitted light to the temperature of the object. So option A, Wein's displacement law, is the right answer. Let's check other options as well. Kirchhoff's law relates to the absorption and emission of radiation by bodies but does not explain the change in color with temperature. Newton's law of cooling describes the rate of cooling of an object and not the color change with the temperature. Let's check Stephen's law. Stephen's law, or is also called as Stephen-Boltzmann law, it states that the total energy radiated per unit surface area is proportional to the fourth power of the temperature, but again it does not directly explain the color change. Therefore, Wein's displacement law is the correct answer.